picking up where we left off, number 2 says diluting solutions. When we're diluting something, we're taking a concentrated solution, which we will call the stock solution, and we are preparing a less concentrated solution. So what that really is we're like watering something down. It doesn't necessarily have to be with water. It could be diluting it with a different solvent, but in general, we're talking about water here. So the equation that we use to represent this is that the molarity of your initial solution, usually your stock solution, times the volume of your stock solution is equivalent to the molarity of your diluted solution times the volume of your diluted solution. So M1V1 equals M2V2, where again, M stands for molarity and V stands for volume. What matters about these is that they are measured in the same units each time. So it's okay in this equation, volume can be measured in milliliters or in liters as long as it matches on both sides of the equation. So the volume that you put in has to be the same units as the volume that you get out. So volume units need to match on both sides. And then for M, since that's molarity, the unit for molarity will already be in molar or moles, whatever. So capital M for both of those. So for example 1, it says, what volume of 2 molar calcium chloride stock solution would you use to make 50 liters of a 0.300 molar calcium chloride solution? So what matters is that you are associating the correct molarity with the correct volume. Giovanni, you want to put your phone up? Thanks. So we're starting with a certain amount of our stock solution. This one we'll call our concentrated solution. So I'll make it look really like strong. So I'm going to take my concentrated solution, which is I'm not sure the volume. We're looking for the volume, but the molarity is 2.00 molar. We're going to use that and add to it until we hit 0.50 liters. So my volume equals 0.50 liters, and my molarity is 0.300 molar. This is going to be a less concentrated solution, a much less concentrated solution. But I know that the volume is going to be higher because we're diluting it. I can tell that we're diluting it because I start with a concentration of 2 molar and I'm ending with a concentration of 0.3 molar. So then we're just solving for that volume right there. It doesn't necessarily matter if you label it as V1 or V2 as long as the correct volume and molarity are affiliated with each other. So I'm going to just call this my solution 1, and then the other one would be my solution 2. So my volume 1 is going to be what we're looking for times my molarity 1, which is 2. That's equivalent to my volume 2, which is, I'll put this in parentheses too, 0.5 times my other molarity of 0.3. So then to solve this, I would multiply 0.5 times 0.3. So 0.5 times 0.3 equals 0.15. And then divide that by 2. Because I get 2 times V1 equals 0.15. To get the 2 away from the V1, I divide by 2. So then I get that V1 is equivalent to what? Perfect. And our unit on that is liters. I know that it has to be in liters because my other volume was in liters, and that's what I plugged in. If the other volume was milliliters, I could plug in milliliters in the equation, and it would give me milliliters out. All right, let's do the next example. So example 2 says, if I have 340 milliliters of a 0.5 molar sodium bromide solution, what would the concentration be if I added 560 milliliters more water to it? So let's draw what's happening. If I have 340 milliliters, so we'll just call that 340 milliliters of 0.5 molar sodium bromide solution. What will the concentration be? So we're looking for molarity 2 equals something, which means that this would be my volume 1, this would be my molarity 1. If I add 560 more milliliters of water to it. So the way that this is worded, and the reason that I like to use pictures for this, is because this is not my new volume. My new volume is not 560. I'm adding 560 milliliters of water to this. So my new level, my V2, is going to be whatever my 340 is plus another 560 milliliters. So I'm going to write that. Do you see how I got that one? It doesn't say that you are adding it until you reach 560 milliliters, so that's not your new volume. That is just added to your initial volume. So your V2 is going to equal whatever 340, which is this, plus 560 equals. So 340 plus 560 equals what? If you don't know, use a calculator. What'd you say? 900. And our unit for that will match the units that it was already in. So that would be milliliters. So my volume 2 is 900 milliliters. And we're looking for the concentration. So I'm going to take the initial volume of 340 times my initial molarity of 0.5, set that equal to my final volume, which is 900 milliliters, times my final molarity, my M2, since that's what I'm looking for. So same thing here, I would multiply 340 times 0.5, 340 times 0.5 gives me 170, and that is equal to 900 times M2. To get M2 by itself, what do I need to do? Divide 900. Perfect. So 0.18 repeating. So M2 equals 0.188 repeating. What is our unit for this number? Not milliliters, but molar. So it's just a capital M for molar. Yes. So capital M stands for molar, or it stands for molarity, depending on the context that it's used in. It will either be the variable or it's our unit. All right, 2 more practice problems, and then we are done with all of our notes for this unit. Example 3 says, if I dilute 250 milliliters of 0.10 molar lithium acetate solution to a volume of 750 milliliter, what will the concentration of the solution be? So this question is a little bit different. So what we're starting with is 250 milliliters, so 250 milliliters of 0.10 molar, that's an M. So I would call this my volume 1, and this would be my molarity 1. We're looking for the concentration. It says, what will the concentration of this be? So I am looking for M2. You dilute it to a volume of 750 milliliters. So does that mean that my final volume is 750, or does that mean that I'm adding 750? So notice in the one where we were adding it, this one says I add 560 milliliters more water to it. That specifically told me that that is being added. So that's what the part that told me that. This one says dilute it to a volume of 750. That does tell me that my final volume, this tells me that my V2 is equal to 750. So that means that your final mark would be 750 milliliters. You see the difference in the way that it's worded? So we're still using our equation of M1V1 equals M2V2. I'm going to change my color. My M1 is 0.1 or 0.10. My V1 is 250. That's equal to my M2, which I don't know, times my V2 of 750. We don't have to do any conversions because this is in milliliters and that's in milliliters. I know molarity is going to be my unit for concentration on both sides. So I would do 0.1 times 250. So 250 times 0.1 is 25. And then I'm going to divide that number by 750. I already forgot what it said. Is this what y'all got? Yes, no? 0.033? Okay. And what is our unit? M for what? Molar. Good. Perfect. They all sound the same. There's molar and molarity and moles and molecule, and all of these things are like, they're really closely related. It's called molar because it's number of moles per liter. But moles is not the same unit as molar. All right, final example. It says, if I leave 750 milliliters, so I'm already going to start drawing this one. Hold on. Okay, so if you leave 750 milliliters, that's a volume, I'll just call it volume 1, of 0.50 molar sodium chloride, so I'm going to call that my M1, uncovered on a windowsill, and 150 milliliters of the solvent evaporates, the solvent meaning likely the water. So if 150 milliliters of the solvent evaporates, what will the new concentration of the sodium chloride be? So if you leave this sitting out on the windowsill and 150 milliliters evaporates, does that mean that I lost 150 milliliters, meaning I'm subtracting it, or does that mean that my final volume is 150 milliliters? You're subtracting it. So you see, you have to pay attention to how it's worded, where you can't just pull the numbers out of it. So this much evaporates, meaning that you lost that much. So our new line is going to be whatever 750 is minus, so my V2 will equal 750 minus the 150 that evaporated. So what is 750 minus 150? Okay, so 600 milliliters is my new volume.
No, wait, no. 500.
No, it's 600.
Oh, yeah.
And then we're using our same equation. M1V1 equals M2V2. We are looking for the concentration that's associated with this volume. So we're looking for our M2. My M1 is 0.5. I'm going to multiply that by my V1 of 750. My M2 is what I'm looking for, and my V2 is 600. Now, just reading this and not even doing math yet, should your new concentration be higher or lower than the original concentration? So can you picture what's happening in this situation? You have a certain amount of salt that's dissolved in your water, and then you leave the water sitting out, or you leave that whole solution sitting out, and then some water evaporates, but no salt is evaporating. So the same amount of salt is now dissolved in less water. Does that make it more concentrated or less concentrated? More concentrated. So we would expect that our number would do what? Of our new concentration number, should it be higher or lower than our original number? Higher, right? It'll be the opposite of what it was for the previous ones, because all of these other ones talked about diluting a solution or adding more volume, watering it down, versus this one is going the opposite direction. So if I do 0.5 times 750 times 0.5 gives me 375, and then I would divide that by 600. So 0.625. So my M2 equals 0.625. Is that what I said? Is that right? And what is our unit? M for molar. And just as expected,
Do we have to write the big M?
yes, that counts as your unit. So you would get a point just for showing me that. If you got a question like this on your test, that's a good point to bring up. If we're doing math of any kind, I always try to give you partial credit whenever I can. And so if you got a question like this on your test, and let's say you just panic and you're like, I cannot for the life of me think of what any of this is, but I do know that we measure concentration in molarity or molar. And you said like M2 equals blank capital M for molar, I would give you that point for showing me the unit, because you're at least showing me that you know something. So it definitely helps you out to remember each of those things. Same thing with volume. If you're like, okay, listen, I don't really understand how to do this problem, but I know we're measuring volume, and volume can be measured in milliliters, so I'm going to put that. Or volume can be measured in liters, I'll put that. I would still give you partial credit as long as it was an appropriate unit for that variable. Are there any questions on any of these problems that we just did? Calculations, units, grading questions? Good? Alrighty, let's cut it off.